As we conclude our exploration of nuclear fusion and its potential as an incredible source of clean and sustainable energy, let's reflect on the transformative impact it could have on our lives and the world as a whole. Energy is the currency that drives everything in the universe and on Earth. We rely on various sources to power our lives. While fossil fuels and nuclear power have played significant roles in electricity generation, their drawbacks in terms of greenhouse gas emissions, air pollution, and nuclear waste have led to a growing need for a more sustainable alternative. Nuclear fusion offers a promising solution. Unlike nuclear fission, which is the splitting of atoms, nuclear fusion involves combining light atoms, such as hydrogen nuclei, to form a heavier nucleus, releasing an enormous amount of energy in the process. This reaction is similar to what happens at the core of the sun, where immense temperatures and pressure create a plasma where fusion occurs. The potential of nuclear fusion lies in its ability to provide a virtually limitless source of energy. Hydrogen atoms, which serve as fuel for fusion, are the most abundant elements in the universe, meaning fusion power does not rely on finite resources that need to be extracted from the earth. Furthermore, fusion power emits no greenhouse gases, making it an environmentally friendly and sustainable energy source. However, achieving practical fusion power on Earth is a complex and challenging task. The conditions required for fusion, such as extreme temperatures and pressures, are difficult to replicate and sustain. Nevertheless, scientists, researchers, and private organizations worldwide are tirelessly working on designing reactor systems that can safely initiate and control fusion reactions. One of the most promising approaches being explored is the use of a device called a tokamak, a donut-shaped chamber that employs magnetic fields to confine and compress a plasma of hydrogen isotopes. Inside the tokamak, the plasma is heated to temperatures exceeding 100 million degrees Celsius, creating an environment several times hotter than the sun's core. The intense heat ionizes the hydrogen atoms, and powerful magnetic fields keep the plasma contained within the chamber, allowing fusion reactions to occur. While tokamaks have shown progress in achieving fusion reactions, challenges remain, such as handling extreme heat and managing plasma instabilities. Scientists are also exploring alternative solutions to overcome these obstacles and develop more efficient fusion systems. Countries like the United States, China, Russia, Japan, and the European Union are at the forefront of fusion research, each pursuing unique approaches to harness fusion power. The collaborative efforts and competition among these nations drive the advancement of fusion technology, offering hope for a future where we can tap into the power of the stars right here on Earth. It is essential to continue supporting and investing in fusion research as we explore the possibility it holds. With ongoing developments, it is highly likely that one day we will unlock the potential of fusion energy and revolutionize our energy landscape.